Hello, YouTube world. So just waiting for a couple more people here, and then we're gonna start about 10 minutes after 7. Okay, so you guys enjoy the background. So you guys know we're live on YouTube. Yeah. That's gonna be fun. Just waiting for one more walker to come there, and I'll start. All right, I guess I'll start. All right, thanks everybody for coming out to the meetup. Really appreciate it. It's a pretty good showing considering it's kind of raining outside. So thanks for getting through the rain and everything. We have a lot of speakers tonight, so that's really cool. I'm actually gonna do a really brief lightning talk on serverless. And then Phil over there, he's gonna talk about Kubernetes. And Alyson and her colleagues can talk about observability and build for that. So we'll kind of kick that off. Let's see. I already did that. I already did all the introductions, and I already talked about all the presentations. So now let's talk a little bit about our sponsor. So the venue here is being provided by Nava. So Brendan, and it has a couple words. Just we should thank him for this great spot and everything. Go ahead.
You're more prepared than I am. No, excellent. Welcome everybody. Yeah, excited. This is our kind of exciting to see that we all fit in the space. We've never had as big an event as this before. Just wanted to introduce you to Nava a little bit. Nava is, the website is Nava PBC. PBC is Public Benefit Corporation. And I don't know, do any of you remember the healthcare.gov website launch? This was about 4 years ago now. And it was not successful. We were meant to sign up, thousands and thousands of people on the first day, and only 3 people could sign up or something like that because the website was completely broken. So Nava was kind of born out of that crisis. The folks who started Nava basically were part of that team of people who went back and got the website running, but also from that also got the government agency to start using AWS and more modern practices, rebuilt like the worst parts of the system, and eventually started Nava. So yeah, we're currently based in DC, San Francisco, and New York. It's actually a pretty small company. It's like 60 people. And it's kind of unique because it's a public benefit corporation, and we're working with government agencies with a mission to basically help the government provide better digital services to citizens. So yeah, I've been here for 3 years, and I'm currently working on the Medicare payment system, just giving you kind of flavor of the kind of things we work on. We also work with the Veterans Administration. So yeah, that's welcome everybody. And if we are hiring. If you're interested, you can talk to me later or look up Nava PBC.
And thank you very much. And for the food tonight, we have Instana to thank. So here's Instana.
Thank you very much. My name is Pete Abrams. I'm hoping you're enjoying the pizza style with sodas and a beer. And for the opportunity to sponsor this, actually, I love the topics that we're going to hear about tonight. Just let me give you a couple words about Instana. We're a startup. We're now 4 years old. Been selling our product for 2 years, funded by Excel and Veritech. We are a next generation APM solution, applications performance monitoring solution, along the lines of AppDynamics and New Relic and Dynatrace, but really specifically designed for exactly the types of architectures that you guys are talking about. Highly agile environments or development style, cloud native, containerized Kubernetes. Our idea is pretty simple. Make it so that the DevOps team, that collective team, only has to do one thing to get total visibility into the health of their application and understand how their services are operating. That one thing is put the agent that we have into the system, into each host, either via a container or natively as a process running on the host. After you do that, we just tell you what's going on with your application, give you a full stack visibility across the whole application stack from the bottom up or the top down, whichever way you want to go. So how are the servers behaving? How are the containers operating? How's the middleware doing in all those containers? How are the services And that's all discovered completely automatically, zero touch, and presented to you as, kind of any way you want it. You can look at it from infrastructure view, from service view, from Kubernetes view. And that's the idea. We're doing exceptionally well. Observability, as you guys all know, is a hard problem. And the more containery, microservice-y, cloudy you get, the harder the problem becomes. And really, that's going to be one of your big topics tonight, obviously. And that's exactly what we attack. So check us out, instana.com. Try it for free. Really simple. So thank you for your patience. Let's get to the show.
Well, thank you very much, you guys. Okay, so presentation time. And I'm actually the first lightning speaker, so I will switch over to this guy and talk about a tool I wrote. Okay, so I'm the serverless part of the talk, and I'm gonna keep this actually relatively pretty short. And I wrote a framework called Ruby Jets. It's a Ruby serverless framework. And I thought a good way to introduce this to maybe a DevOps meetup is actually talk about cron jobs and running down serverless. How to do that. So I'll actually show you how to do that in this presentation. Now the standard introductory slide about myself and who I am. My name is Nguyen. I am a co-organizer of this meetup. I also have started this consultancy company recently, BoltOps. It's focused on DevOps and AWS work. I was very lucky and fortunate and honored to be named a AWS Container Hero recently. Big honor there because there's only 5 of us in the world. I think it's because that tool I wrote up there called UFO. It's that icon with that whale and the Docker and UFO. I have a couple other tools in this space, but the main tool we're going to talk about tonight, right, is Jets, Ruby serverless framework, and how that all works. So I want to start off with saying why maybe even bother creating a cron job on serverless, and so that icon, that dog on that server is supposed to represent a pet server. Now we all know we're not supposed to build pet servers. We're supposed to build cows, not pets. You don't want to a pet Jay-Z where you know their name, or Bob, you know their name. If that server breaks, it's gonna hurt you at night. You have to wake up and you have to fix it, right? You want cows, you want fleet servers. But we all do it because it saves us time. Your time is worth money, right? So what I found is the time is usually in DevOps not really upfront. Setting up the server is actually not that difficult, It's usually 6 months down the line or a year down the line. When all of a sudden you're like, oh, I installed Vault. What version is it on? I'm 3 versions behind. Okay, I don't remember what I did last month. I'm supposed to remember what I did 6 months ago, right? So the time that you pay for DevOps is usually on the tail end, right? So this is what the promise of service is. You don't have to manage that server. You delegate out to a team of hundreds of engineers at your provider, AWS or whatever, right? So that's why this might be interesting for some people, right? Now, the difficulty with serverless is the tooling, I think. So I wrote a tool called Jets, and there's a starter command to actually get you up and running. And there's this one command called Jets new that generates a starter project, and there's a mode job here that generates a very light mode of the project structure. And backer just happens to be the project name that I'm naming here for just the sake of this tutorial, really. And this is the structure it generates from that one command. It generates an app, a jobs, and application job structure there. And what your code looks like is it inherits from the application job. So this is what your code looks like. There's a class backup, and inherits from the application job. There's a declaration rate 1 minute there. And I'm just using 1 minute, it says in the comment, for fast initial testing, right? Because this you want to test out. And then there's a function there, route 53 records. So this job runs on serverless and backs up the route 53 records. Most companies I work with don't back up their route 53 records because nobody has time to do it, right? And then it's something that it's pretty important to do. And then down there, there's just a Jets console. What that does is it starts off an IRB session, right? And then you can actually run the code and test it locally, even before you deploy it. Just backup job.perform now, route 53 records. And then it's just a put statement, because I'm just kind of emphasizing the structure of code there. So we'll see what this code actually does. With these 6 lines of code, you're ready now to deploy everything to AWS Lambda. That's it. So you run just deploy, it packages up your code, and then it deploys to AWS and you're on serverless. So what does that actually mean? What does that actually do? So there's a method right there. That big arrow is pointing to route 53 records, right? And that's a method. That's a Ruby method, but it actually gets translated to a Lambda function that's being shown down the bottom there, right? Any public method within this class definition is translated to an individual Lambda function. Private methods do not. And that's the kind of interface we're working with here. And then you can actually see that function in the Lambda console. And this might sound crazy, but you can actually live edit and you can test it. This actually really shortens your development cycle a lot. Like you can actually develop this across all the Lambda containers live and save it in a browser. That's all you need, right? So that's pretty cool. That's kind of what it does. I want to focus in a little bit on the rate expression. So rate, it says rate 1 minute, but what magic is that doing, right? Like it's saying that this Lambda function, this method that translated Lambda function is going to run every single 1 minute. So what rate does is actually gets translated to another AWS resource called a CloudWatch event rule. And for those who might not be familiar with what CloudWatch event rules are, it's basically a scheduler on CloudWatch. You can schedule actions that be ran repeatedly. And you could give it like a human-friendly term, like 1 minute. You can also give it like Cron-like expression that allows you to like run it in like more like Cron-like syntax. And then what that does is it basically creates that CloudWatch resource, and you see down here in targets, it associates that CloudWatch event rule down with that Lambda function and binds the two together, right? All with literally 6 lines of code, right? So, oops, that's the wrong way. Okay, and then this is just showing how to verify it. Any standard output that goes out of AWS Lambda goes to CloudWatch logs. So you can see that, there's about 3 executions of it or invocations of it every 1 minute. So this is just verifying that it runs every minute. That's pretty much essentially it. And this is actually the full source code right here. I didn't really go through the full source code. I just kind of emphasized the structure. Full source code is completely available on GitHub, available for free download and everything, but that's all it really takes. Only a couple minutes to actually get you go on serverless. So I kept this presentation intentionally short to show you how simple and easy it actually is to get on serverless. Right? It was literally 6 lines of code, right? And also to leave some room for any questions. So if you guys have any questions, happy to take any questions now or afterwards. Any questions? 0. Okay, tough crowd tonight. Okay, all right. So next up is Phil. Okay.
So I'm going to take you on a much less technical journey. It's some architecture not included. It's not completely true, but there's just a tiny bit of architecture. It's more about how we went about getting to our next generation of architecture. Let's start out with.
Down is 4.
It's all over.
I know.
Start out with Looker. So I'm Phil Sharfstein. I'm the Director of Technical Operations at Looker. We are a data analytics company based in Santa Cruz, California, with offices kind of all over the world now. I started Looker about 5.5 years ago when I was the 25th employee there. We're now at about 700 something employees worldwide, including a pretty substantial engineering office up here in San Francisco. As far as ops, for the longest time, we were adding 1 ops person a year, which meant that as of last year, we were at 4 people supporting several thousand customers with an application that's not multi-tenant, which meant several thousand AWS instances spread all over the world in different VPCs. The main way we did that with so few people is just automation. We automated everything. Everything was self-healing. Everything restarted itself. Everything worked great. The one issue is that AWS doesn't really continue to scale that way. Eventually, you kind of hit that inflection point where your AWS stuff is in such a state of failure all the time, and it's in a state of failure where that little tiny percentage of it is going to fail outside of the parameters of your automations, and then you're kind of done for, and your ops team gets to spend all their time waking up in the middle of the night. So we mainly wanted to avoid that. That again. So we went through kind of a year process where we were convincing people that we really needed to change our architecture, getting all our stakeholders involved, getting money for this, because if you do that with 4 people, then you're not going to be able to do anything else ever, including supporting your production architecture. So kind of frame this as Looker 10,000. It was a little bit of a take on Looker 500, which was our yearly thematic goal about making Looker great for 500 customers. But this is about how does the ops team look when we hit 10,000 people or 10,000 hosted customers, which actually could happen at the rate we're growing now. So the whole talk is kind of about going from being a small startup where you can just host people on one instance, which seemed like a great architecture when it seemed like we were going to have a few hundred customers, to our architecture where we're going to be hosting 10,000 customers. First thing we did is our shameless self-promotion. Wrote down some core tenets, and we actually went around and kind of did a lot of focus work to figure out if these were actually what we were. So how we do our most important work. There we are. Everything has to be able to scale independently of the size of the organization. Anyone who's worked at a place where that's not true knows how awful that is. Second, how we organize the team. We had 4 pretty good generalists. Now we need specialists so we can continue to serve our broad range of customers, do new architecture, support the eng team. And data-driven. We are a data analytics company, so that's our core mission. Everything has to be data. And finally, how we work with our primary stakeholders, and that is the engineering team and our customers. So we work in equal partnership with our engineering team. So some of you might be kind of looking at this and going, sweet text fly-ins on a generic set of what DevOps is. But we actually, this is actually true for all of us, especially point 4, where we work in equal partnership with our engineering team. The way we're structured, I work under a VP that runs all of operations and everything that the engineers use as sort of the bedrock to develop the platform. So when he's, his success is kind of when we have both operational and engineering success. Let's see, what else do we have? Take one. You want to figure out who you are. You want to tell everyone who you are and what you do. As we grow, 700 people don't know who we are. There was a point where, it's like I was the DevOps guy. And then there was a point where kind of, it's like me and Graham were the DevOps guys and we did everything. And we had me, Graham, and David, we're the DevOps guys and we did everything. Now we're the size where we can't do everything and we're not all guys. So second step we did is we started to engage stakeholders. Let's see, it kind of looks like this. And here we're going to get into kind of some of the architecture. So unmanageable architecture, that's what we're trying to avoid. We're kind of at the point now where everything still works well, but we know that once we get double the customers, triple the customers we have now, then everything's going to start to be failing. That one instance or cluster of instances per customer just isn't going to work. It's also wildly inefficient in resource utilization. I have a great slide on that one. We want to go multi-cloud because we're currently all hosted in AWS, and there are customers that don't like Amazon for some reason. So people who are direct competitors of Amazon, where like Jeff Bezos knows that they're direct competitors of Amazon, they don't want to host in AWS. The way we're doing that is we're leveraging Kubernetes. So there's a core of Kubernetes that we have, which it takes care of about 80% of hosting in every cloud provider using their Kubernetes service, like EKS, GKS, with a K in it. But then for that other 20%, we're doing a modular architecture where we can just write little pieces of plugin code. So things like a database, where you have an RDS database in AWS, and then you have a Cloud SQL database out in GCP. That's all handled by the modular architecture. And the rest of it's just kind of, just sort of a nice little core that we don't have to touch when we move to a different cloud provider. Final thing is an increased focus in the product and image team on Looker internals. So we couldn't even think of doing something like this until internally in our engineering org, we spun up what's called the core infrastructure team. They're that team that manages kind of the bedrock. So we could come up with any kind of architecture we wanted, and it still wouldn't work well with the product. So we really need buy-in from the Eng team on getting the product to the point where it's going to work with our new Kubernetes architecture. That means making things stateless. We just love to throw stuff out on disk because everyone has a disk that seems to come back when we restart their instances. There's tons of garbage out there that needs to go away for a stateless environment. And that's part of the Eng buy-in, is that we're going to have, we're going to be successful because we're going to get those product changes in. Here's my favorite slide. So just a little personal story. That nightmare I had, that recurring nightmare where I show up to school in my underwear, it's been replaced by me standing in front of a group of DevOps people and showing them this. So this is our actual utilization across all of our AWS instances. And if you know how you buy cloud stuff, everyone does, you pay for capacity. So this white space represents several $1 million that we are using to heat the AWS data center. It's a little embarrassing, but the great thing about this is every time I show it to our CFO, he just throws money at me. So I tell him we can take, $1 million from cost of revenue, let's say, if we can get it up to there, and we can put that into R&D and just hire more developers, and more DevOps people, and more architects. And he goes, sure, that sounds right. Next one, take home from this, data. We all collect tons of data, but getting it into a usable form where you can present it to people and they can take home, they can get really good insights from it. And I suggest everyone use Looker for their data. Next, so here's how we're implementing this. Phase one, make it work. This is a pretty radical change from our current architecture. So what we're doing first is we're making it work with our current, all of the warts that make our current application really kind of not something you'd want to containerize. All of the stateful stuff, all of the various overuse of databases, overuse of files. So we're just making it work now. Step two, we're going to make it work everywhere. So we're going to take this architecture that mostly works. Actually, it does work, just not as well. It doesn't get rid of that couple of $1 million that we're burning away. We're going to make it work everywhere, which means right now we're doing all our development in Google Cloud at GCP. It was the kind of rip off the Band-Aid of AWS API and make everything work in an entirely new environment. But eventually we have to make it work in AWS and in Azure. That's part of our requirements as we try and host as many people as possible in our SaaS environment. Here's where I lied, because here's an architecture diagram. This is actually what we have running in Google right now. It's kind of pretty standard. The kind of big piece that we need to develop is this X. Currently, we have everything in AWS. It all just kind of provisions itself, deprovisions itself, restarts itself. It's a bit self-aware. That X has to replace everything we've done over 4 years with something that works with Kubernetes. So that's kind of it's one of our many kind of really big development projects that we have on this. Phase three, make it work well with the product. That's where we go back to the engineering teams and they just take care of us. So they're going to get rid of everything that we've recognized as a deficiency in the product to make it run efficiently in Kubernetes, and just take care of it so we have a really good, well-working product. Phase four, make it the platform. Go. That means that our engineering team gets to change the way they do development. currently they do development, there's a single jar file, and they just develop to that. And every time they have to do a release, you have to make sure everything works correctly together so it can be packaged in a jar and all work. Once we're really bought into Kubernetes and the development team has taken care of all of their deficiencies, then they can really start using something like a Kubernetes service mesh. And this is kind of what gets them really excited. Right now, everyone has to develop in Java and JRuby. But at this point, like message queue, that could just be some external service. Syntax checking, rendering, that could be like a node service. These guys could be little Java services. So it kind of really empowers the engineering team to do development the way they want to do development, instead of being locked into our little kind of Java and JRuby world. Let's see, circling back. Remember those 4 core tenets. Here's how they're kind of serving us as we go through this process. So why are we developing this next generation architecture? It's our first core tenet. We need to have scalable things that just kind of run themselves. Why are we building this dedicated architecture team around this? It's our second core tenet. We have to structure it in a way the team that can keep doing everything. How do we influence our stakeholders? It's that data. It's collecting data and having it in a presentable format. And finally, how are we going to optimize our application for the architecture? And that's because we have that equal partnership with our development team. And that's it.
I look at a bar graph with a lot of empty space. Have you guys ever tested like using like preempted instances on Google Cloud or like Sparks, like those cost down units?
Yeah, I mean, the problem is we're a Java application, so we need to go cluster, which would instantly double the cost of everything. So it takes 5 minutes to start up our application. So that's 5 minutes of downtime if we want to be in a more elastic environment, which doesn't seem more elastic. But once we're in Kubernetes, we'll be able to oversubscribe things and bring up cluster nodes. And if they're not quite working yet, then we can kind of coordinate shutting down a smaller node, bringing up a larger one. Right. Anything else?
I'm just curious, were there any in this decision-making process of like a really big re-architecture, was there any pressure to look at more incremental approaches and like?
Not really. When I started walking around talking to everyone about Looker 10,000, we didn't really have an architecture. It was kind of that we needed to change our architecture and sort of, best of breed architecture now is a Kubernetes and container based. So it kind of developed through that. And then we hired on the architect and he just kind of goes, this is kind of easy. Just make it look like this.
Yeah, okay. And so the DevOps team kind of was the ones who carried the torch for this and got everyone.
Yeah.
Yeah, okay.
In terms of numbers of your engineering workers, how does that like developers, what would be a main
About. So the teams I manage are the DevOps team, where we are now up to 7 people with another kind of 4 open positions. The architecture team, which is still just 1 person, who's awesome, because he's done all of this. And we have like 3 open positions with him. And then there's something called the Cloud Services team, and they kind of make our little servers, like our licensing server, off servers, and little standalone things. And they are 3 people right now with another 2 open headcount. Developers, we are close to 100, and just about evenly split between Santa Cruz and San Francisco. Yeah.
Is there any monitoring setup for this?
No. Yeah. So we're using Datadog right now. That was part of this new architecture. We were using Zabbix in a way that it was nearly falling over if we monitored everything. So there's just stuff that we didn't monitor. Then we switched over to Datadog. They're a customer of ours. So I assume we got a deal on it, but they're one of our bigger customers. So the entire negotiation just was taken out of my hands and went on it like the VP and the C level. And then they said we can have it. So.
You mentioned you have like a cloud systems team building what sounds like snowflakes, maybe?
Yeah, kind of. they're kind of standalone servers. So they're sort of production support servers or developer support servers where something to do our licensing, or we have our own internal OAuth, and that's one of the servers they support. So there's kind of a multi-directional push there that the cloud services team is going to be doing. Remember that box with the X on it? That would be a big part of their work since they're a pure development team where DevOps also runs into the ops world. And then there's kind of the push from the other direction where things like a licensing server, and licensing is kind of a solved problem for, I don't know, 50 years now maybe. So we want to get them out of kind of the business of building stuff that already exists in a way that we can just buy it and get them into developing kind of, our core standalone servers that are kind of snowflakes.
Why keep the two teams separate? I mean, the fact that they're building snowflakes to me is a red flag that maybe there's not enough automation.
Well, I mean, things like licensing and OAuth, it's kind of, we decided to build those ourselves at some point. Sure, it wasn't my decision, but we did. So, we do kind of want to do the right thing, but it's getting the capacity internally to do the right thing sometimes, but you already have momentum doing possibly the wrong thing. But I mean, that is a point.
Okay. All right.
All right.
Alyson and Alaina, you want to go? All right. Okay, great. Thank you so much, Phil. Okay, so we're just back from a short break, and we have our two next presenters here. I'm going to go ahead and start the slides. Okay, so we are going to start the next presentation, guys. Whenever you're ready, just go for it.
Yes. Hey everyone, I'm Alyson. I'm a full stack front-end leading engineer at Honeycomb. I'm Alaina Valenzuela, also an engineer at Honeycomb, also kind of full stack-ish. And before joining Honeycomb, we worked together at a different. Okay, got it. Okay. For those of you who may not be familiar, Honeycomb is a tool made for debugging and understanding complex, mostly distributed systems. It's a tool for observing your system. But what even is observability?
Jeremy Majors is one of the founders of Honeycomb, and as some of you may know, basically wrote the book on observability. We are at Honeycomb because we, of course, believe in her vision. And in this talk, we will build and expand on this definition of hers by viewing the concept of observability through the lens of our day-to-day work.
So what is observability? For us, the concept of observability is a bit more holistic than charities. It encompasses both systems and their users. Specifically, observability gives teams insights into how their systems and their users function. This might sound a bit like monitoring, but it's a lot more complex. With monitoring, you set up an alert based on a metric, and you get notified when it fails. Whereas with observability, it's a lot more than that. Because as we know, distributed systems, they fail in a lot of ways we can never anticipate. Observability is a bit like a language you can use to communicate with your system. It allows you to answer questions that you didn't anticipate having to ask. And even then, asking those questions is only the first part of the battle. Observability allows you to dig deeper into your system data and get at the underlying problem.
So conversations around observability tend to focus on its technical implementation. You instrument your app, you send the data from that instrumented app to some tool, and then you use that tool to query and inspect the data to gain useful insights about your production data. Following this line of thinking, you could have one brilliant engineer instrument your app, set up the pipeline, and then people on your team might ask that one person what's going on in production, and that one person would find out via the observability tool. So does that mean that this team has achieved observability? Well, this is where we think the definition kind of falls short of it. What I've described leads to a single human point of failure. The team is no less empowered, and only one person has access to this really important data about the system. At Honeycomb, we've seen this happen again and again with our customers. We're constantly being asked, how can I make this more of a priority on my company? And how do I get more of my team members on board? Alyson and I believe that cultural practices need to shift in order to maximize the value of any technical observability implementation. We witnessed this firsthand in our transition from our former company to Honeycomb. And in this talk, we'll describe some of the differences in culture that we believe have created a positive feedback loop where all team members, including non-engineers, are excited about observability and use it in their day-to-day work. And this stuff is important. Because of these cultural changes, we've witnessed a faster development cycle, faster time to issue resolution, and improved software quality. And that's just on the engineering team. We've also witnessed positive business outcomes throughout our organization. So in general, these cultural shifts center around having no single human point of failure, democratizing knowledge, and encouraging thoughtful questions about our production data.
So to illustrate the importance of the cultural practices and how important they are in maximizing the impact of system knowledge, we're going to share with you some of the key differences between our old company and Honeycomb. At our previous company, questions weren't encouraged. I'm sure you've all been there. Generally, information and answers weren't sought after. People just did their individual jobs. If a service failed, the ops person would just say, restart it, we'll be fine. There was very little insight into the overall health of the system and what the services did or how they even interacted with other services. There was a lot of gatekeeping of knowledge. For example, new hires were generally discouraged from touching the backend code until they had displayed or passed a set of criteria that wasn't acknowledged or talked about. Senior engineers often took on pet projects to create new services, and then they get defensive when other engineers try to contribute or improve upon them. Well, the engineering team sizes were about the same between the old company and Honeycomb. There were a lot of different teams at the old company. There was QA, there was ops, there was backend, there was front end, and generally no one knew what was going on with the other team. The front end team would write some code and throw it over the fence to QA. Ops wouldn't really know what a service did or what other services it needed to interact with. Backend and front end teams didn't know what the others were working on or when they would ship. And when somebody left the team, it left a huge hole that was ultimately basically impossible to fill. These cultural practices ultimately prevented us from growing as individuals, connecting with the rest of our team, and driving the product to success, despite the fact that there were many smart and experienced people who were on the team and had knowledge of the system.
At Honeycomb, our labs are much better with a culture of observability. Questions are encouraged, and in fact, people lust after knowledge and dive deep to answer very specific questions. This curiosity spreads from being able to ask just about any question about our production data, and also feeling comfortable asking questions of and learning from our teammates. There's a lot less division between teams and a lot more emphasis on software ownership. When we write a feature, we're responsible for testing it, deploying it, and making sure it's functioning in production. While we do have people who are more back-end, infrastructure, or front-end focused, in general, the lines are pretty blurry, and there's definitely no gatekeeping. People are always very willing to explain how something works if we express interest. For on-call, we have a much stronger precedent for uncovering the underlying cause of issues, and we also empower new hires to start learning about the system as a whole and asking questions about it from week one. So setting aside the technical aspects of instrumenting your code, a culture of observability increases your team's productivity through sharing knowledge and empowering team members to gain insights into your production data. Based on our past and present experiences, these are some specific practices that we believe contribute to a culture of observability. Ensuring there are no single human points of failure, creating engaging onboarding strategies, developing tools that allow us to asynchronously shoulder serve our team members, and facilitating blameless, learning-focused postmortems.
In our team, we don't want anyone to be a single point of failure. But of course, people are always going to have their areas of expertise, though we want everyone to be able to keep our product. One way that we do that is putting every single engineer on call. And we don't just do this to democratize the knowledge about the system. We also do this because we really fundamentally believe in the power of software ownership. We want everyone to have a stake in the success of the product, to feel like they own their code from start to finish and beyond in production. We want everyone to have the power to jump in and fix things. We also don't want everyone for people to feel like there are only 2 experts on a team who will solve everything. It makes the team so much more resilient. If you only have 1 or 2 power users and something breaks, how are you going to fix it if they're awake? Another advantage we found to putting all engineers on call is that it really levels the playing fields between beginners and experts, or even front-end, back-end, and infra-facing or focused engineers, because asking questions is okay and expected on our team.
So putting all engineers on call may sound like a tall order, but in our onboarding process, we empower new hires and get them thinking about the system as a whole from week 1. One way we do this is by giving new hires a series of puzzles about our product and asking them to find out the answers via our observability tool. Let me give you a few examples of some of these puzzles. Determine the data set sending us the most traffic in the last 2 hours and figure out whether they're being rate limited or not. Which team is responsible for this data set? Another one is, we forgot to instrument a new feature, but we know what endpoints are involved. Figure out how many users tried out the new feature in the last week. Who is using it most often? But my favorite part about these puzzles is they start to get at how the system is actually implemented. For example, one is, find a data set running slow queries. What qualities of the queries seem to make them slow? And this starts to get at how our columnar data store is implemented. So along the way, we provide hints and pair the new hire with a buddy so that they can ask questions. We also put these puzzles in context, explaining the overall goal of each puzzle and also why you might want to answer a question like that in your day-to-day work. As a bonus, they're actually really fun. We both found them pretty challenging at first and started coming back to them as our knowledge of both the system and the observability tool. One other way that we empower new hires to start asking questions is by giving a technical infrastructure overview to every new hire, including non-engineers. I'm sure this happens at a lot of companies, but one thing we do differently at Honeycomb is that we have the last newest hire give the infrastructure overview to the newest hire. And we believe that this helps everyone feel that they have some level of expertise about the system. Of course, we do have more senior engineers there on hand to answer any questions, fill in any gaps, and also to contribute some color commentary. So this image is an actual puzzle that one of our marketing team members made. It started off as a completely blank slate, and our whole team put it together over a series of about a week, and we thought it just reflected nicely the onboarding puzzles that we have here.
So another key part of our culture of observability is the ability to shoulder serve asynchronously with our team members. One way that we do that is by creating places to add inline annotations in our observability tool. And we encourage those with the expertise of the area to also add those inline annotations. There are lots of different ways to do this in many different observability tools. For example, we annotate our alerts with detailed runbooks of what data might be helpful to look at, what might illuminate the underlying cause of the issue. This has really helped bring new team members up to speed when being on call. We try to make a habit of adding those inline annotations wherever we can to leave breadcrumbs for ourselves and for others. We've even set aside an hour at lunchtime for everyone to start just dumping in those annotations. These annotations become documentation, but they're so much less fragile. Instead of having a doc or README that details how the system works, lives elsewhere, and easily gets out of date, you're doing it in line. You're able to join those annotations with the data that you're looking at. And when the system changes how it's behaving, you're able to update it as you go and keep digging in deeper to get to the answer of the question you're asking. By reading someone's past documentation, you're able to have insight into what they were thinking of when they were solving.
So one of the cultural practices that's nearest and dearest to my heart personally is blameless learning-focused postmortems. This type of postmortem acknowledges that human error is basically inevitable. And instead of pinpointing why someone made a mistake, we shift the focus onto how we could have minimized the impact of the human error in the first place through more robust engineering practices. They foster experimentation and help drive system and process improvements, in my opinion, more than a blaming culture.
So at our old company, I fucked up. We've all fucked up. We've all been there. And the way we drove postmortems at our old company is through the 5 whys, which was designed to ask why after why after why to get at what caused the issue in the first place. But ultimately, it ended up in me saying, it was me, I fucked up. Oh, god damn it, we all have. Then it went down the path of, well, why did you fuck up? And how can we keep you from fucking up again? And it just really led to that laying blame on the person rather than changing processes.
In contrast to that, at Honeycomb, I accidentally erased an entire field in our production database. And that wasn't even the worst part. The worst part was that there's a cron job that runs about every 10 minutes, and the absence of that field could have wiped out pretty much almost all our customer data. So it was pretty bad. Yet, instead of blaming me for the problem, our more senior engineers remarked, oh, this is actually great because it exposes a key vulnerability in how we handle data. And even a customer absentmindedly tinkering around with this field via the UI could cause negative consequences if they were tinkering around and the cron happened to run while they were still figuring things out. So the postmortem that we had focused on how we could handle the data more safely to lessen the impact of the human error, instead of how to eliminate the human error or the human itself. So throughout the incident, I was really amazed at being super frustrated that he had to set aside the work he was doing for that day and figure out how to restore a database to its previous state. My coworker Travis remarked that, this is actually good because I'm not too familiar with this process, and now I'm more familiar with it, and also I can document it for future people. And my coworker Ben, instead of blaming me for this mistake, welcomed me into the fray of production engineers, engineers who make production incidents. So I was really grateful for this mindset. Of course, I was already beating myself up, almost ready to show myself out the door. But the attitudes of my team members really turned this into a positive point for both our team culture as well as our product. Because as I said before, these changes we made around how we handle the data resulted in a more system.
The democratization of production data and empowering of team members shouldn't be limited to just the engineering team. Once we gave the whole company access to our production data in our observability tool, we not only improved the product development cycle and increased software quality, but we also improved the quality of our customer support, and we really eased our sales cycle. For example, sales is now able to tell if how much data teams are ingesting. This allows them to proactively reach out if customers are entering a higher pricing tier, giving them the chance to get another sale. They can also see what features a team is using. Given that team's history, the sales engineer might suggest using a new feature if it matches up well with that customer's goals. Support's able to look at customer-specific issues, even if it's only happened to that one customer one time. This results in exceptionally direct customer support, and users are generally motivated. Another key difference with how our observability production data is handled is that we use that knowledge proactively. In other words, observability isn't just for what we should build and how we should build it. And if you don't have that knowledge, you're just guessing at what the users are doing. For example, we track general user interactions. And then we use that instrumentation to see if a feature is being used and if it is successful, if we should continue building on it, or if it's a failure, if we should revisit it or just pull it out entirely. Right now, we're working on instrumenting these user events as traces, so we can see how long those user actions are taking, how we can.
So no matter where your company is along its observability journey, we bet that there are still some cultural practices that you can adjust to more fully take advantage of your production data. When you're looking at the processes that you have at your company, maybe ask yourself, does this help empower my team members to ask questions? Does this help them find the answers in our production data? If not, what barriers might be in the way? We hope that soon you all
Time for questions. If you don't want to ask them here, or whatever, you can reach out to us via email or on Twitter. If you want to try playing with Honeycomb production outage data, you can do so at play.honeycomb.io, or you can look at our blog to read more about our culture of observability through users. Yeah.
Love the talk. You're my people, observability people. And it's interesting, I'm kind of like scanning my like career history, all the companies I worked with, and I feel like I was the one in the organization who like wanted just to know like what was going on. And
Yes,
was like wanting to get
observability.
more
You want to know?
more monitoring. But honestly, I don't feel that, I never really felt like that was a common trait in people. And for the most part, most of the organizations I've worked in wanted to get like kind of a certain level of observability to kind of get some boxes checked off, like make sure you're doing your on-call monitoring and alerting right and that kind of stuff. I'm just wondering, I think one of the insights I maybe wanted to ask you about was, feels like you're using observability not just for like what you're saying, debugging and alerting, which is the kind of thing that I don't want to get woken up in the middle of the night, but
For sure.
like
Nobody.
to create that, to bootstrap that kind of culture, what are the keys to that? What do you think of?
I think pairing with people and showing them how they can get to the, like, see the data and see it in action and see like, oh, these customers are using this feature. This is how I can see that. Oh, this makes me think about like, oh, we should build more on this thing, and oh, nobody's using that. Let's just delete that and get rid of it. It really drives our production that way.
Yeah, I feel like we've just found that it's pretty much contagious in the organization. Once, you know, a PM, a sales engineer, a customer support person sees that they can find out things that they never knew before and be able to translate that into insights that can help them be more productive at their job, people just seem super hungry for it.
Cool. Yeah, I think that's kind of what's been missing for me is like, I'm thinking about my operations team and I'm thinking about developers being on the on-call rotation, but not thinking holistically about how to get more than just the like, you know, DevOps people interested in it. So
Yeah, it turns out
it
that
can
people
grow.
just love finding the answers to the questions. Like any question you can dream up, almost like we can find a way to answer it with the data that we.
Yeah.
It's the like data driven. Just show them the data, and they're like, yes, data, do this.
Cool.
We did also bring some infamous honeycomb stickers, which are ridiculous quotes, as Seth can tell you. So please help yourself to find them.
Okay, thanks guys. So those are all the presentations for tonight. And let's hang out and talk and chit chat. Thanks guys. I'm going to end this now.